everyone, welcome back to another video, and in this video we are starting a complete Docker bootcamp or course or whatever you want to call it. It's a part of the complete DevOps bootcamp that we are running. You can find all the links in the description. If you're a beginner, if you don't even know what programming is, we have courses for that. We have like introduction to data structures algorithms and introduction to now DevOps, complete bootcamps. Check out the link in the description, and we're coming out with more and more content regularly. So what is this video about? This is the first video on Docker. It's an introduction to Docker, but it's not like just the basic stuff. Okay, we'll do a deep dive. We'll see what Docker is all about, why we are using it, how did it come into existence, what all the problems the Docker is solving. We'll do a little bit of like exploration of the Docker concepts. We'll try to see what the installation is going to be like on Windows, Linux and Mac, and we'll see like obviously hands-on examples. We'll see how you can use Docker in your daily life. We'll see how you can utilize Docker as a developer and also where it lies in the DevOps scenario. So basically, is it okay to say this is the only Docker course you're gonna need? Yes, okay to say that. Now, Kunal, that's fine, but we want to learn some more advanced stuff. So that's going to be coming as well. We'll learn about Docker networking, Docker security, Docker best practices. We'll learn about Kubernetes, Docker Swarm even, Docker Compose even, right? Things you may not even have heard if you're obviously beginner at Docker. So we'll learn about how the containers are working and lots of command line tools. So it's going to be a big course and it's going to be a great course. So make sure you like, share, subscribe, and join the Learning in Public initiative. You can check out DevOps with Kunal on Twitter. The students are giving us a shout out if they're liking the courses. So yeah, make sure you check out all the links mentioned in the description. Share your feedback and show your support, because this is free and you can support us for free by liking, sharing, commenting and just learning. Cool. So let's get started with Docker. Okay, if you are watching my courses, you know I never directly jump onto the main stuff. Okay, I will first compare why we are doing it. Okay, what happened, how did it come into picture, what was the problem that we're trying to solve. Okay, so let's talk about the past before Docker, what used to happen. So there are so many enterprises and companies, like they're running their own applications, for example, right? And if the applications go down, your company will offer significant amount of like loss and stuff. Okay, now for a beginner, where are these applications running, you may wonder. Okay, servers, you may have heard about servers like data centers that companies have. They run their own, some companies run their own servers, some borrow servers from big providers, and other like cloud providers and stuff. So the idea is that these applications are running on these servers. And what used to happen initially when the companies were just starting out with applications and stuff, computers just came into existence. Initially, very first time, applications were running on server. What used to happen was that only one application will run on a server. One application on one server. This is a very old story. Okay, initially how it used to happen. You have a server over here. You want to run an application. Your application is running in this server. Okay, 200 people are using your application. Now let's say 2000 people start using your application. Obviously the load will increase on this server. What do you want? You want more and more servers running your application. So before that, when they were learning like Windows and stuff and like Linux and all these other things, they didn't really have a way to run multiple applications on a server. Okay, so for example, if you want to increase the applications running, you would have to add a new cluster, add a new server basically. Okay, buy a new server if you want new applications. Okay, I will buy another server, hard disk and everything it contains, CPU or whatever. I will add my application on it like this. Okay, so every time you want a new application, you have to buy server. This was the world we used to live in. This is not cool, both in terms of like environment. You need more and more hardware running, and cost as well. Imagine your company wants to start a new app, an instance of another app, or like a new version of an app or whatever. You have to add a new box in your server room or whatever, right? Who solves this problem? VMware. So VMware is a company. VMware solved this problem. How? virtual machines. We all know what virtual machines are. Even if you don't know what virtual machines are, you may have heard about virtual machines, right? Dual booting and stuff like that, you may have heard about it. But if you don't know what virtual machines are, let's cover that. Kunal, that's fine, but what is like virtual machine doing? Remember this thing when I talked about one application on one server? Virtual machine solves this problem. Solves this problem. In simple terms, you can run multiple applications on the same server. Okay, but there was a problem with this also. What was the problem? You may have heard about it when you may have used about it. The biggest problem here is that virtual machines require their own operating system. Okay, so for example, operating systems use like your CPU and your RAM and some dedicated amount of hard disk or whatever, right? So it may not be always that, okay, all the things that are allocated to this operating system, they're this part of OS, they are being utilized or whatever. Okay, there comes issues with like licenses of operating systems and stuff as well. All right, so even though it was better, far better than just one application on one server, it was still not perfect. Okay, you need to have a new operating system if you want to use like virtual machine. Even right now, if you try to dual boot your computer, you'd have to install a new operating system. It's a Windows on one end of your hard disk and a Linux distro like Ubuntu or something on another part of your hard disk. It's going to take some time. So these were like the flaws of virtual machines. Not super fast. You need a dedicated operating system, which in turn leads to dedicated like storage, dedicated like your own softwares and CPU allocation and RAM allocation. Like, okay, this operating system is allocated this much amount of CPU, this much amount of RAM or whatever. Okay, better than before, but still not perfect. What are a few more problems? Let's first, forget about Docker. Okay, right now let me explain to you what the problems were. Okay, cool. This is the very past scenario. Okay, let's look at some newer problems that you may have encountered if you're a developer. For example, you build an application. Okay, you made a nice little website and everything, and you give that website to your friend, and you're like, hey, this is all the source code and everything. Please try to run this and give me feedback on your own system. Your friend is also a developer. Okay, because that's what we do. We developers, we build stuff and we share with each other. Okay, so your friend is like, oh, dude, it's not running on my machine. It's saying this version is missing. It's saying this module is missing. It's saying that this version is, deprecated, or some newer version you are using, and you, my friend, are using some other version. I'm using some other version. It is not working for me. And then you say the most, popular line, it works on my machine. That's what you tell your friend. Like, it's working on my machine. What do you mean it's not working on your machine? Okay, so such issues with like having various dependencies, modules, packages, and this it works on my machine stuff. This is what that Docker is trying to also solve. So forget about Docker. Right now we're just comparing like the problem. So one of the problems were like the virtual machines problem. You need a operating system. Other problem is like your dependency management. Another problem is like it works on my machine. It doesn't work on your machine. And if you want to shift your code from one particular point to another particular point, that migration may also be some time consuming. One more thing is you're contributing to open source and you want to set up the project on your local system. That can be a very tedious task, right? So now open source organizations, they have used Docker. Using Docker, you can just set up the project like this. How, we'll talk about later, but forget about Docker right now. Okay, so these are all the problems. Okay, these are all the problems. Now let's look at the solution. Okay, so comes into picture, we'll talk about Docker later. Let's talk about how they're solving this virtual machine problem. Like, what happens with virtual machines is, like I mentioned, you're using a new dedicated operating system and RAM and resources, everything it consumes. Okay, companies started to think like, hey, wouldn't it be cool if we had this isolation, right? Our applications are running in isolated environments, but I don't want to install a new operating system, for example. So what I mean by isolation is that you have dual booted your computer. Okay, on one part of your hard disk you have Windows installed, another part of the hard disk you have Ubuntu installed. Now what's going on in Ubuntu? Windows has no idea what's going on in Ubuntu. Ubuntu has no idea what's going on in Windows. You can create so many virtual machines like that, right? But the problem is that every virtual machine will require its own dedicated operating system and hardware and resources and everything. People started thinking, wouldn't it be possible if we had something that would not require us to have a dedicated amount of hardware allocated or whatever, and a operating system installed, everything, and we can just use the one that is provided to us. Okay, so if you're using Ubuntu, then I want to create these different applications. So virtual machines, you can run many applications in different like virtual machines. Wouldn't it be cool if you can run all these different instances of your applications on the same machine, same operating system? Not like virtual machine, like dividing operating, like installing a new operating system. No, the one operating system only. Run your applications on that 100 or 10,000, whatever, how many applications you want to run. This problem is being solved by containers. Containers. Forget about Docker, okay? Just learn about like containers right now. Okay, so companies like big companies like Google and stuff, before the containers thing was popular, spoiler alert, like it was made popular by like, Docker made it popular with like Linux containers that were coming into picture. Docker made it popular to like for folks to get their hands on these things. Okay, like more and more developers using it. One thing I was mentioning, shortly was about like containers that I'll go into deep of it, like what containers are, how they work and everything. Right now, you can just imagine like, yeah, big companies like Google and stuff, before they were popular, they were already using containers and stuff in a way. Okay, and not just that, there were like many other initiatives like containers that folks were using previously, but it was not like really popular. Okay, so Kunal, what is the container and what is like the difference between container and virtual machine? Okay, so containers are basically, it's sort of like what virtual machine is doing, but it's not like you require an entirely new operating system to use it or whatever. Okay, let me show you a diagram. Okay, so if you go to my newsletter blogging website kunalkushwaha.com, make sure you check it out. If you go over here, you can check out my blog on Docker, right? Getting started with Docker. So when we talk about containers, right? When we're talking about containers and stuff, so this is what I mentioned previously. So imagine you wanna let's say share something with your friend, okay, that lives in another country. You're like, hey, I want to transport this, or you're a person who transports stuff, and like, hey, I want to transport this particular car and this particular piano and stuff from India to the US. How do I do that? You can be like, okay, car is going to be transported in different way, piano will be transported in different way. You're like, oh, never mind that. What I'll do it, I'll just put everything in a box and I'll give that box. I'll ship that box. This box is basically what a container is. Technical definition I'll tell you in this video only very shortly. Please stay with me. Okay. So similar example with your friend. You're like, hey, you give your website to your friend. Your friend is like, this is not working. That is not working. So your code of the website, the database, the front end, the back end, the, all the things required, the source code and dependencies and operating system, everything required to run your website. You put that in a box and you give your box to the friend. Now it will make sure that that website runs on your friend's computer. This box is basically what is known by a container. Okay, we'll talk about these things when we talk about Docker and containers and images and Docker files, everything I'll cover right now. Okay, but coming to the picture of containers and virtual machines and stuff, this is what I wanted to show you. So in virtual machine, you can see there's this infrastructure, hypervisor. So what is a hypervisor? Hypervisor is used to create multiple machines on the host operating system, and it manages the virtual machines. Okay, so these are all the virtual machines, one operating system, second operating system, third operating system. Okay, and every operating system will be dedicated some amount of hardware and resources and CPU. This will be on one machine, but virtually it is divided in 3 parts. That is why it's called virtual machine. Okay, so hypervisor manages all these things. So as you can see, new operating systems being created. Container on the other hand looks something like this. Container is like, okay, you have your own laptop over here, whatever, your laptop, or you're using a cloud, or you're using like your own database server or whatever. Okay, you have one operating system only, and on top of that you have a container engine. A container engine. On top of that you can run such applications. So you can previously see what is happening. 3 applications you are running. In virtual machines, how do you run multiple applications? In multiple operating systems. In containers, how do you run 3 applications in the same operating system? Using the container engine. This is what is known as Docker. Docker allows us to do it. Docker is what? Docker is a tool. Okay, I'll tell you more about Docker shortly. Okay, so as you can see that containerization, we used to deploy applications. It encapsulates the application in its own environment. So this application this application, for example, will not know what's going on outside it. Okay, if on my Mac I'm running a particular, let's say, container in a virtual machines or whatever, so it's not like, for folks often ask, which is better, virtual machine or container? It's not a this or that question. In reality, containers run on top of virtual machines. It's a mix. Both are things are happening. Okay, containers will run on top of virtual machines and stuff. Okay, so that is about like containers. A little bit of a technical definition is given over here. Forget about Docker right now. I'll tell you about Docker later on. Let me tell you a little bit like about a little bit more, build the intuition in your mind. Okay, so before moving forward with Docker as it is, let's talk a little bit more about like containers. So what happened was that these companies like Google and many other contributors, like open source contributors, they contributed towards the container related technologies in the Linux kernel. So Linux containers are the one that got really popular. And after that, Docker came. Docker is a company. We'll talk more about that later. And they sort of like made it easy for other folks to use Linux containers, for example. Okay, so you know what containers are. The technical deep dive of containers we'll do later on. Obviously, we'll run our own containers. We'll see how you can create containers, how you can modify containers, deploy your application in containers. For now, just have a basic understanding of what they are doing. Okay, your application is running in an isolated environment. Docker helps us in doing that. Docker is a container tool that allows us to create container, manage containers, scale containers. So Docker is what? Is a tool. Docker is also a company, Docker Inc., right? So that's basically what a container is. How is it better than a virtual machine? You can see we can just use Docker and we don't have to install new operating systems and allocate the operating system resources or whatever. No. Okay, so Docker helped us in like making containers like more popular. Kunal, does it mean that containers don't run on Windows? That is not true. Or Mac? That is not true. You can definitely run those. And now let's see how you can get started with that. So you can run containers on Windows. Microsoft has worked a lot with Docker and other companies to make this happen. In Windows, you can install Docker Desktop. Okay, so you can run like for example, it's important to know this, because if a particular application, right, if you're running a container, okay, in a container our applications run. Okay, how it runs or whatever, please don't worry about it right now, please. I know it can be overwhelming to and impatient to understand. Okay, Kunal, we know how what it's doing, but how is it doing it? Please have some patience, we'll cover that as well. So inside your container, for now, imagine it's a box running on your host operating system, and in that your application is running. Okay, if that is more than enough right now. When we learn how we can actually do that, then we'll do the deep dive. Okay, so example, you're running a container, okay, that is on your host's operating system and like interacting with your host kernel. It basically means that if a Windows app is containerized, it will not run on a Linux based Docker, for example. Okay, similarly for Linux based Docker, it will not run on Windows based Docker. All right, so that's why Windows container will require Windows host, Linux container will require Linux host. All right, so for Windows you can install like Docker Desktop. Docker Desktop you can run in 2 modes. You can have like Windows containers, you can have Linux containers as well, and you can use some hypervisor and virtual machines. You can create a virtual machine in Windows and run containers on that. Or what you can do is WSL. This is the appropriate way that I will recommend, WSL. I will share resources. Check out the links in the description that will help you in the setup, installation and everything. I'll share those and I'll mention more about it right now. So that is not going to be an issue. But just saying, if you're using Windows, use WSL, Windows Subsystem for Linux. Okay, WSL and Docker Desktop. Cool. I'm using Mac. So what about Mac? You cannot, there's no such thing as like containers on Mac or whatever. Mac containers, MacBook specific, macOS specific containers or whatever. No, you can have virtual machine for Mac. So VMs and Docker desktop. If you're using, if you are using what? If you're using the new M1 MacBooks, right? Docker desktop is the way to go. Okay, so you can run it using Docker desktop. All right, and with Linux, it's no problem. You can run it on Linux as it is. As it is. Steps and everything I'll mention soon. What Docker desktop is, what even Docker is, Docker architecture, Docker commands, and all these other things I'll mention right now. Cool. So let's move forward. All right, now let's look into Docker. So what is Docker? As mentioned already, Docker is a container platform. So all these containers things that we talked about, right? Docker helps us in making those containers and deploying those and creating those and scaling those and all these other things. Okay, that's it. Docker is basically like it's a company and it has a tool not called Docker, right? So they're focusing on they have like a Docker desktop and they have Docker hub over which we can post our own like images, which we'll talk more about later. Right now as it is, but yeah, if you want to learn more about like what I'm telling you in this video itself, you need a summary. I've written a blog on kunalkushwaha.com. You can go over there and you can also subscribe to the newsletter. You'll get all my articles for free. Okay, so we talked about like why use Docker, but Docker is basically like a container platform that allows us to do this. Okay, let's talk a little bit more about installation, and now we will, after the installation, we will look into what like a little bit more about Docker and a little bit more about like containers, technical deep dive, architecture, how it all works, demo, and all these other things. So go to this website docs.docker.com. Over there you'll see two options. You'll see Docker desktop, Docker engine, Docker compose, hub. Not too many options. So if you're using Mac or Windows, you have to download Docker desktop. Okay, because Docker desktop includes all these other things also. If you don't know what Docker compose is, what Docker hub is, or whatever, don't worry about it. Okay, we'll cover it. Okay, Docker engine, Docker compose, Docker hub, everything we'll cover. Okay, so what I wanted to mention is that if you're using Mac and Windows, you can see that Docker desktop, it's very easy to install application for your Mac and Windows, and you can use it to run your containers and everything that we'll be doing. And you can see that it also includes Docker engine, the CLI client, the command line tool. We'll be learning command line in this video itself. Docker commands, for example, Docker compose, which allows us to add, basically connect multiple applications together, Docker content trust, Kubernetes, and all these other things. All right, what Docker hub is or whatever we'll cover in this video soon. So download it and all the information can be given over here. Very simple. Same for Mac and Windows. So you can go to Mac, you can go to install, user manual, everything is available over here. Okay, for Apple Silicon and all these other things mentioned over here. Now for Docker engine, for as you can see over here, Linux distributions. Okay, and speaking for Linux, you can check out like the Docker engine you can install, because desktop, I believe it's like they're working on it for Linux, but you can install according to your distro like CentOS, Debian, Fedora, and Ubuntu or whatever. Okay, so go to this. As you can see, all the commands and everything is mentioned over here already. So if you're working with Linux, you already know how to install all these things. Okay, sudo apt-get and everything. If you want to learn more about Linux commands and like networking, like terminal commands, check out my video on terminal commands. I made an entire course on that. You can check it out. Install it via packages. So if you work with Linux, you know all these things already. Okay, so as you can see, entire information is given over here. So again, docs.docker.com, you can check it out and you can download it. And now let's look into the learnings. Okay, now let's talk about Docker in itself. Okay, how Docker works and what Docker contains and everything. All right, so far we know, right, that Docker is basically helping us to run our applications in isolated environments. Okay, our application will run in a container using containers, and this container itself is known as an isolated environment. Means container will not know what's happening outside it or whatever, even in the operating system. Okay, so that way you can run so many containers, it provides security and so many other things. All right, so we'll talk more about containers later on because I want to do a deep dive on that, but this is some basic information about Docker that I wanted to share. All right, so let's talk a little bit more about the Docker part. So Docker, as you know, the company, it's a tool that allows us to do all these things that I just mentioned. Contains a few parts. So let me just write those. The first thing is the runtime. Okay, the Docker runtime. I'll draw a diagram as well. Let's draw the architecture for this. Okay, so we have a runtime. Over here. All right. There's also something known as a Docker engine, something that I just showed you on the Docker website. There was a Docker engine. Okay. And there's also something known as that it comes with shipped orchestration. Let's look into it like in a little bit more detail. So what is the use of the runtime thing? Runtime basically allows us to start and stop containers. Okay, so all the things you need to make and everything, and it basically allows us to start the container, stop the container. Okay, so the runtime is of like two times. One is the low level runtime, which is known as runc. So the role of this runtime is basically to work with the operating system. It works with the operating system and starts and stops the containers. Okay, that's the role of this. Second one is container D. There's a CNCF project, container D. Container D. Okay, this sort of lies on the higher level of the hierarchy, and the role of container D is basically managing runc, and it also helps in managing containers, but it does stuff like how to interact with your container with the network, like the internet, for example, how to get data from the internet into the network, which is also known as like pulling the images. You may not know about what image is. Okay, so we'll talk more about images later. So all these things happen with container D. Okay, every Docker container will have runc and it will also have container D. Container D also like manages the runc. So runc is using to start and stop. Container D does all the other things like getting data, connecting with the network, outside world, or all these other things. It's also used in the Kubernetes runtime. So you might have heard about the Docker shim thing, the deprecation of that. It does not mean that way. Never mind. If you know about Kubernetes, then you can research about it. If you don't know, then when we cover Kubernetes, then I'll tell you about all these things that happen. All right, let's move forward. Nothing to worry about. You can still use your Docker containers with that, but yeah, container D is also now the container runtime for Kubernetes. Okay, the next thing is this Docker engine part. Okay, I'm not making notes as such because I don't like making notes. You can do if you want, but I think making notes does not work for me. Okay, Docker engine is something that we use to like interact with Docker. For example, like Docker daemon is over here. Docker daemon. Okay, let's see what that looks like. So you have something like this. You have your Docker daemon or server is running, server and like your Docker daemon. Okay, so this is a server. Kunal, what is a server? It's basically the Docker server that is running. There's some REST APIs provided over here. Okay, API via which you can communicate like, hey, Docker, create this container. Docker, delete this container. So you can communicate via the Docker CLI. That's it. So using the Docker CLI, using a REST API, you can make an API call to the daemon, and daemon will work with the container runtime and do it. Via the Docker CLI, I'll write Docker command, Docker run Ubuntu. Docker CLI will be like, okay, I'll give this to the daemon. Daemon will be like, hey, container runtime, Kunal is saying, please please run Ubuntu in a container. So I'm like, yeah, sure, no worries. Cool. So that's basically about it. It's using a client server architecture, as you can see. So this is the client. This is a server, client server architecture. All right. Cool. So that's the thing. So Docker daemon, it's basically listening to the API requests and manages all the Docker objects and stuff. And objects we'll look into later on, like containers and images and networks and volumes and all these things. The Docker client is basically what we use to interact with it. And we can either use a CLI, you can also use graphical interfaces and all these other. What do we mean by orchestration? Let me give you a hint of this. Let's say your application is running in 10,000 containers, okay, and you want to scale it up, or let's say you want to scale it to 20,000 containers. So you can do that. Let's say a few containers got ruined, 500 containers got ruined. You want to restart those containers, right? One more thing is possible, that your Docker is available, like this is Docker, let's say. Okay, this is Docker server running, and over here you have many containers running, all have version 1 of application. You want all of these to be version 2 of application. What do? To stop the entire application and then update it, or you update it once by once. Okay, you may want to make ruling updates and all these other things. So this is very time consuming if we do it manually. So many monitoring and everything will be required. Wouldn't it be cool if all these things happen automatically on its own? This is just a tip of the iceberg. Okay, it does a lot more. So that's where comes into picture orchestration engines. Okay, there's Docker Swarm built in, and there's the most popular one that many folks use, Kubernetes. Kubernetes is much more than an orchestration engine, okay, but it's one of the functionalities that is provided. So in simple terms, it allows us to manage containers. That's it. Very simple. All right, let's move forward. Okay, let me tell you an important point. Now we're moving on to the next part. So I will tell you in brief about these two things, and then I'll do a deep dive after I explain this. Okay, the first point is about, there's this thing known as, containers. Okay, containers are running your applications inside it. So what happens is that, let's say you are making a dish, you have a dish, you are eating something. Okay, you're eating a bowl of noodles that has like vegetables in it and as well, and your friend lives in another country. Okay, let's say Sayam lives around, let's say, Bangalore, okay, for example. So I'm living in, let's say, New Delhi, different cities and states. So I'm like, hey Sayam, this noodle soup is amazing, would you like to try it? Someone's like, yeah, sure. But I'm like, okay, you are in Bangalore though, how can I give you my noodle soup? Here, take my noodle soup, I'll ship it in a box, take your noodle soup. Does that make sense? No, because by the time the noodle soup will reach Sayam, it will be like very bad, right? And also it doesn't make sense to share the running application to my friend. Okay, instead what can we do instead? We can instead share the instructions, or I can share with Sayam the recipe. I'm like, hey, here's the recipe, make it yourself, and then you can also enjoy it like I am. Similarly, when you're running an application, dude, check out this great website I'm running. Oh, how can I do that? Here is the entire instruction with the source code and everything. Run it and you can do it. Okay, so this instruction part, when you're following a recipe, okay, this particular thing, we call it like that you follow an instruction and you follow the recipe and the dish will be created. Okay, so the dish is the actual application that is running in the servers inside where? Containers. Okay, no problem. But what leads us to creating that dish? That is known as a Docker image or a container image. So if I want someone to run my application, I can just create an image of my application and share that image, and then when they run the image that I have shared with them, the application will start. So image is what? It's just a file that contains all the instructions and everything. Okay, and container is a running instance of an image. You can also create Docker images using something called Dockerfiles. Dockerfile is your recipe. Download, let's say, Node.js, run this command, copy these files, run this command, expose this port, so on and so forth. So I'll go a deep dive into this. Okay, don't worry. Dockerfile, you run this, you will get an image. You run the image, you will get your container. Okay, when you have your own application that you want to containerize, you have to write a Docker file for that, and it will be converted to an image. That image you can share to other people. Okay, please don't be confused between Docker file and image. Okay, image is basically just something that has been created from a Docker file. Okay, I'll tell you, one second. Let me give you an amazing example for this. Image is a template. Okay, if you have watched my object-oriented programming playlist, this can be represented as a class, and this is an object. Now it will be clear. Okay, this is a class, this is an object. You can refer to this as class, you can refer to this as object. Okay, what is a Docker file? Docker file is something that I can use to create a class, basically. Okay, so you need this container will have many dependencies and all these other things, and files and OS and all these other things. So how do we know what things are available? It's all mentioned in the image. You create the image using a Docker file. Docker file contains a list of instructions. Okay, list of instructions or something. I hope that is clear now. Okay, it will be more clear when we do the hands-on of this. But important point I want to mention over here now. So what is happening? There are many container runtimes, as you can see over here. Container runtime, the container D, run C. There's also LXC. There's Rocket RKT. There's Cryo, right? So there's so many, Kubernetes, not Kubernetes, like normal container runtimes. Okay, so the problem is that like folks were like, hey, which one should I use? Should I use container D? Should I use RKT? Oh, and if I'm using container D, does it mean that I cannot use RKT? Or what is happening over here? Confusion. Folks were like, okay, this is not going to work. They came up with this solution known as Open Container Initiative. It's a project under the Linux Foundation. Open Container Initiative. You can check out this blog and Docker OS OCI runtimes. Okay, so many container runtimes were coming into the market that the Open Container Initiative were like, they started two things. They started a runtime spec and an image spec. So runtime specification and image specification. You know what images are? So they provided some like sort of like basic rules and stuff that they have to follow. Similarly for runtime specification, they did the same thing. Now this is something you can see over here with Kubernetes and Docker. Like they mentioned that Docker as an underlying runtime is being deprecated in favor of runtimes that will use container runtime interface for Kubernetes. So Kubernetes, using the container runtime interface, you can basically change all the like container runtimes, that a plugin that enables in Kubernetes to use a lot of like variety of container runtimes. Okay, so what happened was they were like, hey, we are not going to be, we are going to deprecate Docker for this. Okay, people freaked out. There's no reason to do that because as you can see over here that as I mentioned, Docker is Open Container Initiative, OCI. Okay, Docker complies with this OCI, right? A Docker specific image, it will comply with this. But here it mentions that any OCI compliant image, regardless of the tool you use to build it, will look the same to Kubernetes. So both container D and Cryo know how to pull these images and run them. So as you can see, container D, so many container runtimes, container D and Cryo or whatever. Now you'll be like, Kunal, what is the difference between a container runtime and Docker? We already covered that over here, right? So it's a part of Docker. The entire architecture will cover like later on how that works, and we'll talk about shim and all these other things as well. But right now that is what I wanted to mention. These are just like open container issues, just sort of like rules and stuff that they have provided. Okay, like okay, it's like basic specifications they have mentioned. On top of that, you can modify it like accordingly and make yourself stand out or whatever. Okay, but the basic stuff should be same. That's basically what it's. Let me give you a little bit of a hands-on teaser. Okay, so don't worry about it if you're not able to understand, because we'll learn it from scratch. Even I'll show you how to create your own images and everything. But this is what Docker desktop looks like. Okay, don't worry about if you don't understand these things. We'll cover it later on. and you can sign in or whatever, and you can see the images are mentioned over here. It's a Node Mongo to-do application that I created, and I created an image out of it. If I share this image with you, it will be of 800 MBs, and you can run this image on your Docker desktop. You will basically, it will be running the application that I created, right? There are some of the popular tools that are already available over there. So for those tools, images are already available online. In Docker, remote registries online, so in the clouds, for example, Docker Hub, or private registries as well if you want. So that's known as Docker registry. How these things work and how this flow happens, I'll talk later. So for example, I want to run Ubuntu. I'm going to just say Docker run interactive environment Ubuntu. How this is working, don't even think about it. Okay, I'll cover that later on. Now Ubuntu is running. Okay, on the right hand side, Mac is running. Left hand side, Ubuntu is running. You want to see all the running containers? Docker PS. As you can see, Ubuntu started 12 seconds ago. How cool is that? In just a few seconds, I was able to create it. Make sense? This is a demo I wanted to show you. Okay, deep dive we'll do later on. Okay, don't run this right now. No need to do it. Let me explain the theory part, and then we'll cover the rest of the stuff. Okay, so we talked about like the basics of like Dockerfile, image, and container. We are just right now, we have only learned what these do. Okay, not like how it works internally, all the deep dives and everything. So we'll cover that shortly. But before that, I want to show you a little bit more about where Docker lies around the DevOps thing. So you may not know about DevOps. Let's see. This is the picture. Okay, what is DevOps? So DevOps is a set of practices. Okay, a set of practices. Two words, dev and ops, like development and operations. You make something, build your website and stuff, and the operations part is what? You deploy it, you maintain it. You're like, okay, my application is now running. I'm also operating it, I'm monitoring it, I'm seeing if something is going right or wrong, updating it, and so on and so forth. Okay, so this is sort of like the cycle of DevOps. You first, let's say you plan, then you code it out, right? In the development, then you build it, and then you test it, then you release it, and then you deploy it. Using the deployment, you deploy it, let's say on cloud. For that, you use stuff like Docker and stuff. Okay, operate on it. Kubernetes is there, Ansible is there. Then you monitor it, monitor using dashboards, Prometheus, Grafana, or whatever. Then you again plan it, again code, newer versions keep coming. Okay, I'll make a separate video on DevOps later on, but for now, let's talk a little bit more about what Docker does. Okay, so when we're talking about this DevOps thing over here, okay, so you're doing two things. One is, let's say you made your own application, then you create what? You want to create a container out of it. So you want to create a Docker file, right? You write the Docker file, and then you write, let's say, your own, like create an image for it, then you make a container of it, and so on and so forth. Ops in ops, you can do something like you download an image. Okay, don't care about, you know, like the what's inside, like how it was made or whatever, but like you're downloading the image, running the image, okay, operating on it, all these are things. But writing the Docker file and stuff and all these things, you have to create the image, because you know you are developing that particular application. So you create the image, create it using the Docker file, and we'll do that in this video. Okay, so if you're not using containers, right, this is why containers are great when talking about like that. If you're not using containers, the operations team needs to handle all the, hosting and deployment and all these other things, okay, that your application requires. But since you're using containers, you can use whatever you want, whatever profile you want. You can use Node.js, Python, machine learning, like whatever you want, okay? As long as you're like creating images out of it, you can sort of like then deploy. Okay. The ops part is not really seeing, the ops team is not seeing how you are creating that image. They are only seeing the final image. Okay. Cool. Let's do a little bit of hands-on as well shortly, so that you'll get more clear understanding of what images are, what Dockerfile is, and how containers run. Okay, so let's move on to it. So let me just revise what we have done so far. We learned about runtime, what they are. We learned about ingest, daemon, Docker, this thing, and then we learned about Dockerfile, image, and container. Okay, cool. So let's move forward. Okay, so let's say we go to our terminal and we just write docker run hello world. That's it. Let's see what happens. It's saying unable to find image hello world locally. Okay, pulling from library hello world. That's it. So now it's saying hello from Docker. This message shows that your installation appears to be working correctly. What happened? So many things happened. What is this latest? What is this hash number? What is this pull complete? What is this thing? Okay, what are all these things? Let's see how it is working. So we are saying docker run hello world. We are saying the command we are running is docker run hello world. What does it mean? Docker means Docker, like it's a Docker CLI. This thing we are working with the Docker CLI, the client, it's going to the server, to Docker server. It's saying, hey, run hello world. Okay, what is run? Run basically means you run an image to create a container. You run an image to create a container. Isn't that what run is? That is what run is. And this is what? This is image name. Image name. So as you can see on the screen, when I first ran docker run hello world, it will be like, hey, you don't have hello world image on your local computer right now. So I am going to download it. From where is it downloading? From the Docker registry. From here. From Docker Hub, I believe. Okay. Then it's downloading it. Each image, we'll go deep into images as well. We'll go into hash layers and everything. So it says for now, just simply I'm saying it has downloaded the image and then it runs that image and now that image is run. That's it. Similarly, I can say docker run in the interactive environment Ubuntu. It will run it very fast. Why? Because right now you can see it did not show me the message, hey, Ubuntu not present in local system. Why? Because Ubuntu image is already downloaded on my local machine. You can see all the images. You can say docker images. These are all the images that are downloaded on my local machine. As you can see, hello world is the one that I just downloaded. Mongo, Ubuntu, these are already downloaded. Hence, when you run it for the very first time, when you download an image for the very first time and it is not present on your system, it will take some amount of time to download it. But when you run it again, like I'm running it again like this, then it's running it very fast. Okay, let me show you a little bit more about it. Okay, about this particular line only, docker run image name. Let's dive deep into it. Let's do one more thing. Let's run the docker run hello world command again. Now you can see it's not saying, hey, I can't find it in the local system. It is available in the local system now. Okay, so what happened was, first what happened, let's see. This is my blog. So what is happening is when you're running the docker run command, for example, I'm saying docker run hello world. So it's going to be like, hey, is hello world, it's going to talk, your client is going to talk to your daemon. We already covered this, the circle diagram I showed you. Daemon is going to be like, hey, do I have the docker run hello world, the hello world image, do I have that on my local system? So I'm like, no, you don't. Then it's going to go to the registry, Docker Hub registry. Say Docker Hub. Image library. People are sharing their images over here. All the popular tools like MongoDB and stuff, their images you can find over here very easily. So it's going to be like, okay, I don't have it on my local system. I will download the image from internet. I'll download the image from internet. So example, hello world image. This is the one, hello world image. So it downloaded from here and then it downloads on my local system. Then it runs that image and it forms a container. What does it do inside the container? It just says hello world. It said hello world and then it stopped the container. I hope you are able to understand this diagram. So here we talked about the registry part. Registry is very simple. It's the online repository. Many cloud providers have their own container registry. So all the images you can find over here. You want to find the image for Flask. You want to find Flask. So this is great when you're doing like hackathons and stuff as well. you want to, let's say, run MySQL, or you want to run MongoDB on your machine, but you don't want to install it. Just spin up a container like that, Docker run Mongo, Docker run MySQL, that's it. Okay. There are few things about it, like the hash values and layers and stuff. I'll image ID and the tag, what is this thing, I'll tell you that shortly. Okay, so I hope you are able to understand this container thing. Okay, container is running inside my Docker. Docker is a tool, so it's basically communicating with my own operating system only, but it's isolated. Hello world running inside container, Ubuntu that I just run inside the container, it has no idea what's going outside the container. Okay, that's basically what containers are, isolated environments in which you can run your applications. Okay, cool. Question, you may be having a doubt, Kunal, your Docker image that you're running, that's fine, you're running hello world or whatever, how is it running? Like, what is inside this Docker image that is allowing me, so forget about hello world, you're running a Flask application, or Kunal, you're saying run MongoDB in a Docker container. So we know that when we are running applications in a computer, we need operating systems for that. Okay, you're running MongoDB, you need operating system for that. Where are you running MongoDB? In the magical world? No, running it in an operating system, right? So when you're running it inside a container and you're saying that container does not communicate outside the world, then where is this MongoDB running inside the container? Is there something else inside it as well? Because we need operating system to run all these things. The correct answer is yes. So when we talk about Docker image, they also contain operating system files and the application like MongoDB and the dependencies for that application as well. Okay, so like I mentioned, image is a class. So when you download something like MySQL, it also contains, like, inbuilt, its base image has, when you talk about layers, it also has a little bit, like, often a smaller version of, like, an operating system as well, that it can use to run the main application that we're trying to run. Okay, sound good? All right. So one more thing I want to show you is that you can directly download the images as well if you don't want to run those. So you can say Docker pull MySQL. Now it's downloading MySQL from registry. It's saying no matching manifest for Linux ARM. Okay, I can download something else. I can say, let's say, download Docker pull. I can say Ubuntu, but Ubuntu is already present. If you don't provide a version, it downloads the latest one. Okay, so if I say Docker images, so here I'm saying Ubuntu version what? Latest. But if I want a particular version, I can say Docker pull Ubuntu 16.04 using the comma dot 16.04. Now it's going to download that. It's downloading. This thing forget about right now. Let's see layers. We'll talk about layers later on. Layers and digest and everything. These two things we'll talk about later on. Now if I do Docker images, two Ubuntu are here. One Ubuntu is the previous one that I downloaded, like created 7 months ago, and one is the 16.04 version. And it's only like 119 MBs. Okay, that is basically about it. We'll, in the advanced topics, we'll talk about how you can reduce the size of your Docker images as well. All right, so that was about like tags and images. So it went online, downloaded it, and that's it. Now if I run Docker run interactive environment Ubuntu, now specify the version 16.04, it will run in the background like this. Interactive environment means don't exit out of it. Since I am inside the container, this means I'm inside the container right now. What is this root @ this thing? I've already covered in the Linux commands video, so check it out. So here basically it means that, okay, if I'm inside this is a, like a terminal stuff that I have inside the container. So container itself has its own operating system, in this case Ubuntu. All right. No, one more thing I want to show you was these are the processes and stuff that you can see over here. This has no idea about these things. So this container is isolated. Okay, hope that understood. So this container is running. It only sees, okay, two processes are running, this one and this one, for example. It has no idea these are running as well in my MacBook. Okay, you want to see all the containers that are currently running? Docker PS. Currently Ubuntu one is running, and this Node Mongo to do application I was running some time ago, 5 months ago or something. Okay, let's move forward. Okay, and similarly you can also do Docker container list ls. This will also show you all the containers right now. Sound good? That's basically about it. One more thing I want to show you is when you're running Docker run this per version, and then you have something like, let's say, Docker container ls. So you're seeing Ubuntu is running right now. If I just copy the ID of this container as well, so every container has an ID. So I can also attach my so when I ran this command, right, Docker run -it Ubuntu, it basically means that I want to go inside this container when you run it. Okay, interactive shell. You can also attach the shell. We have also talked about shell, like bash, shell and stuff in the previous video, so make sure you check it out, the Linux commands video. But if I run this command, if I just say docker container execute exec interactive shell, and I say bash, so basically I'm saying the bash shell should be attached to this running container. This command will not work if your container is not running. Okay, so now you can see I have attached it to running container. So if I say something like list, if I say touch hey.txt, so as you can see both of these sessions are in the same container only. If I do list over here, you can see hey.txt is present. So both shells are attached to the same container. So this command that I mentioned, this one, basically means the bash shell should be attached to this container, this running container, so that you can go inside the container and do all the things you want to do. Okay, because these images and stuff have their own operating system, and you can run commands in that. Okay, let's try running something. Let's say docker run mongo. Cool. Mongo running. Okay, you can also check out to stop the containers. You can say docker ps this, copy the ID. You can say docker stop ID. So you can see container is stopped. You can also use the stop command for that. You can also check out if I say docker ps-a, this will also show me all the containers that are stopped. Okay, so this one is, for example, stopped. I can remove this container also. I can say docker remove. So now this is gone. Okay, so many commands we learned. Docker run, let's say we run Ubuntu again, so we can also say docker the ID, say docker inspect Ubuntu, or you can also paste the ID if you want. So here it's saying, it's giving me all the information about this container. You can see over here. Cool. Here's the information about the image. Okay, state of the container, path, ID of the container, when it was created, it's currently running, right, and process ID and everything. Here you can see all the information you need is available over here. Okay, network information is available over here. So right now you may not know much about it, so don't worry. I'm just trying to explain to you the basics, and then we'll dive deep into it later on. Cool. So like that you can run various tools and stuff. Okay, you can also check out the logs. You can say docker, let's say logs of this no worries. Or hello world. Where is the hello world one? It's gone. Okay, no worries. You can see Docker logs. Here it says all the things that were output, right? They are mentioned over here. So you remember I was inserting these commands and everything. So there you go. Cool. So many commands are there. Okay, let me show you one more thing. I say docker docker container prune-f. What happened? It deleted these containers. So -f is basically saying delete all the containers. Okay, all the ones that are stopped. Cool. So prune is deleting those. Okay, so prune is basically a command that is deleting all the stop containers. -f basically means like don't ask me again, just do it. Okay, that's it. If I just go to docker ps-a, I will not be able to see any container. All the stopped containers are deleted at once using prune. Now sometimes you may want to have like containers that are running for a really long time and running, let's say, in the background, for example. What is a good use case for this? Servers. So I can say something like, let's say, the Alpine image. So I can say docker run Alpine, and I'm going to ping co.com. Okay, so it's going to say unable to find it locally. It's going to download it, then it's going to ping co.com, pulling, and it's downloading some layers that I previously downloaded, say already exist. Now it's pinging co.com, as you can see. Okay, I can go over here, docker ps container is running. Okay, I can stop it. Container stopped. Very cool. If you want to run it in the background, you can say docker run in the detach mode. Okay, Alpine, and I'm going to say now the command I'm going to give it ping co.com. What is this thing that it has returned? It has just returned to me the ID of the container, and you can see in the background this container is running. Very cool. So Alpine is nothing, it's just a image based on Alpine Linux. Okay, and it's a complete package index, only 5 MB in size. So since all images are based on like the Linux kernel, you can run the Linux commands like ping or whatever like this over here. Okay, that's basically about it. You do something like docker run Ubuntu echo hey. That's it. This particular thing is it's going to run it. This basically means it's going to put whatever you put over here, it's going to put it in the terminal of it. And say, okay, put hello, hey, this command, echo hey, that's it. Please make sure you have watched the terminal video, otherwise you will not understand the basic commands. So whatever you put outside, because any container, see, any image that is running in Docker, right, the base is Linux kernel. Okay, when you're running it like on like I'm running it on this like on Docker desktop on my Mac. Okay, so I can run Linux commands on that. Cool. All right, so that was about how you can run it in the background. It has just returned me the container ID, and that's basically about it. Okay, you can copy the first few items of the container ID. Let's say I copy 4, and I can say docker logs this. So right now you can see this is all the data that it's providing. Okay, so this has basically shared all the data like from the beginning, but let's say I don't want that. I only want, let's say, since the last 5 seconds. So I can use a since tag. 5 second, this, oops, not that, was the container, I forgot, 9694. So only in the last 5 seconds it has given me this. Okay, cool. You can also stop it. You can say stop the container, docker stop the container. It's going to stop it. Okay, done. Docker remove the stopped container. That's it, container removed. Docker images, you'll see Alpine image. And also remove this image if you want. Docker remove image, force remove like this. Okay, remove the image. We are only doing basic stuff right now. When learning about all these tools and stuff, please make sure you focus on what it's doing, because how it's doing, if you don't know what it's doing, then how it's doing will get a little bit difficult. First understand what it's doing, then ask me questions later. Kunal, okay, we know what it's doing now. How is it doing it? How is images being built? What are the layers and stuff that we're mentioning? What is the pulling thing that was happening? We'll cover that, don't worry. How containers get started, how images are built, how it's so fast, what are the concept behind it, how networking works, for example, everything we'll do. Okay, for now, let's revise a little bit quickly. So we know Docker in containers, it's running inside the container. Our images are running, which are based on like Linux. So they're running inside it. Okay, what if we want to access it? So if I'm saying Docker, let's say we're running Nginx. So I can say Docker run in detached mode Nginx. Okay, but the thing is that Nginx is running on, let's say, what does it run on? Port 80, right? I wanna access it on my own local port. Okay, so let's say I want to access it on port 8080. This is known as port, like it's forwarding the port. Let's see. Oh, sorry, I was unable to. I had to mention my dash p as well for port. There you go. It's saying Nginx not available. Downloading it, pulling all these layers. I'll tell you what layers are later on. Okay, don't worry. Port 8080. Let's check it out. Nginx. So this Nginx is running on my local system right now, in my container, and I'm accessing in my local host. What is happening? Port forward. So this p switch that I gave, it's taking two arguments over here. The port that you want to expose it to, like this one, is the port of the container. Okay, so if I'm talking about Nginx port, even if you don't know what Nginx is, just you can see it's a web server. Okay, Nginx default port 80. Okay, so Nginx listens to port 80. If you don't know what ports are, check out my networking video. You will not be having any doubt in this thing if you have watched my networking video. Okay, so port 80 basically means, like MongoDB has port 27017 or something. Okay, so inside the container, okay, for now only remember this, inside the container Nginx is listening to port 80. Outside the container, you need to run it on your own local system also without any Docker or container, it will still listen to port 80. But what if I want to access it using like localhost or something on my computer? I want to access something on my computer that is running inside the container in my computer. So I'm saying whatever traffic is inside this container's Nginx container that's running, the port 80. So forward all the requests that you're making to the local host 8080 inside the container's port 80. Sort of, you can imagine a tunnel going on. So whenever I go to localhost 8080, it will forward it inside the containers 8080. Okay, that is basically what is happening. Cool. Here the D switch we can put it or don't put it, but since we are using like a server stuff, then we can basically have it. Okay, so this is the image, so I can check out the logs for this as well. There we go. I made a get request and it's mentioned over here. See that? Get request was made, right? So that's basically how servers run in Docker and containers. Cool. You can stop it. Okay. Never mind. Copy pasted the wrong thing. You can stop it. Can remove it. That's it. Docker networking is a little bit more of a deep dive topic. On that, I'll make a separate video. So I'll make separate videos on like more advanced topics of Docker, such as Docker Compose, Docker volumes, Docker networking, images and containers more in depth, right? Some Dockerfile best practices and various development environments for Docker, right? So it's not like we are skipping stuff. We are just setting the base. It's the first video. Many folks who are watching are beginners who never knew about Docker. So you have to keep up the pace as well. Okay. So that was about some forwarding stuff. Now, sometimes it may be possible that you want to share your container and you made some changes in your container and you want to share that with someone. Okay. And you want that particular change to be visible in that. So for example, I'm saying Docker run interactive environment Ubuntu. It will start a new container. Okay. No problem. There we go. List and everything. I say something like, let's say Docker PS, this container is running. I'm going to copy its ID. Okay, no problem. Let's say I make some changes in this container. I say make a new file, names.txt. Okay, and I'm going to add, hey, my name is Kunal inside names.txt. If you don't know these commands, check out the Linux commands video. Okay, you can see names.txt is present over here. That contains this line, hey, my name is Kunal. What I want is I want to create sort of an image. If I run the Docker image again, Docker run this thing will not be available over there, this names.txt. Why? Because it's creating a new container. Okay. And the thing is that I want to be able to share this with my friend. So how do we share the container stuff with our friend? Using images. For example, I have downloaded the Ubuntu image. You all must be downloading the Ubuntu image. The world is downloading the Ubuntu image. What if I want you to download the Ubuntu image that contains, hey, my name is Kunal? We can use commit messages for this. We can use commit messages for this. Okay. If I exit out of it, the container will stop. Okay. Container will stop, but I can start it again. Docker start. What was the... I think this was the one about a minute ago. Yeah, that was it. Docker start this container. Okay, so this container is now started and I can go inside this container as the bash shell we already talked about. Docker container execute, or you can just say execute interactive this thing and put bash here. Okay, we've covered this line previously already. Inside this container, I want to execute interactively this bash shell. Okay. Names.txt is available over there. Okay, cool. What do we need to do now? What do we need to do? So what we can do is that we can copy this thing and we want to create a new image out of it. So whenever someone runs this image, it should have this names.txt file and as it is in it. Okay, exit out of it, no problem. So the way we can do that is using commit messages. Okay, so we can say Docker commit message. I can say something like added names.txt file. Which container do you want to commit? This one. And then you can mention image name. Okay, so you can mention the image name over here now. So I can say something like names Ubuntu. I can give it a version as well. If you want, you can give some version 1.01. That's it. Docker images, names Ubuntu, image is created. Tag is also given, image ID and everything is given. Okay. Docker PS, I can just stop this container. I can say Docker stop, container is stopped. Docker images. Only worry about what we are doing. Don't worry about how it's working internally and everything. I told you a little bit about how much you need to know how it works internally already. pulls it up from Docker Hub, runs it on your system, and that's it. I told you about the interactive shell and everything you need to know. Okay, and let's run the names Ubuntu image now. Docker run interactive environment. Oh, sorry. 1.01. Names.txt is available. Cool. That's Docker commit. Very easy stuff. Let's move forward. You can also do one more thing. You can say Docker images -q. So it's only giving me the IDs of it. Okay. So let's say you want to remove all the images at once. Okay. We know you can remove individual images with Docker remove image like that. But what if you want to remove all the images at once? I can say something like, Docker remove image. Docker images -q. Docker remove image. This thing, copy, paste. Okay. You can also do force. Oh, it's a running container. Okay, no problem. Docker images. You can see only Ubuntu is left because it was running. So when a container is running, it was not able to delete its images. No problem. Docker ps this container, I can stop it. Then I can remove it. Oh, sorry. Docker images, Ubuntu. No containers, sorry, that are running. No images. All the images are deleted. That was a little handy trick that you can use. Okay. Let me show you one more cool thing. Docker run Ubuntu. Okay. 16.04, let's say. Right now, is it on my local system? No. You'd have to download it again. Unable to find it locally. Download it. Why? Because I deleted it. Downloaded it again. No problem. Download it. Pulling it from library. What is this thing? What are these 4 things? These 4 things. What is this thing? These are layers. Let's talk a little bit more about it. So in my blog, you can see that when we're talking about images, so images are built in layers. Every image is an immutable file, but is a collection of files and directories. So Ubuntu image itself is a collection of 4 images, not images, 4 files. Why? Because, why? This is an important point. Very simple point. There may be a possibility, because since everything is based on Linux kernel, there may be a possibility that if you're downloading some other image, let's say MongoDB or something, it may use some files that are also being used by Ubuntu, for example. And since you downloaded the Ubuntu image, does it make sense to download those files for some other images also? Let's say there is a file A, and that file A is being used in the Ubuntu image also, and let's say MongoDB image also. When you download the Ubuntu image for the first time, it will download all the files A and file B or whatever that is required. When you download MongoDB, that is using the same file A, and that is already on your local system because you downloaded Ubuntu. Does it make sense to download that file A again? No, because it was already downloaded using Ubuntu. So some files may be there that are being shared by many images. Hence, images are built in layers. So every layer has a hash value like this. Okay. So whenever you're downloading, see, ID calculated via the SHA-256 hash value. And if the layer contains content is like, like if I say Docker images, and copy this, it will only give me the hash value like that. Let me just show you real quick what I mean. Okay. And I can say Docker images. So you can see that the image ID is equal to the first few values of the hash value of this image. Okay. If I say something like Docker inspect this image, 4 layers are in this image. This image has 4 layers. Okay. When you download some more images, some other images, MySQL, MongoDB, whatever, it will check, is there a particular image that is common? If it is, then it will not download that image. That is why it's extremely important. This is what makes it fast. So if there's a particular layer of the image that is already downloaded on your system, it will not download it again. Okay, cool. That is basically about it. You can say Docker run, let's say hello world, for example. Unable to find hello world locally, it's going to download it. Pulling, this layer already exists. This layer already exists. Okay, so that already existing, it may be only already downloaded in my computers with some layers when they were previously downloaded for some other images. Okay, so that's how it makes it fast. Don't download things that are already downloaded. Okay, very simple stuff. Okay, so this is not just it. I'll cover more into details of containers and images. Okay, how to tag images and all these other things, like all these like stuff we'll do. In my blog, containers, you already know, running instance of an image and image types and layers and everything mentioned over here, and all the commands like docker ps, docker run, docker start, docker kill, which basically stops a running container, deletes a stop container. Docker stop is also something you can use for this. Docker remove, this thing we already covered, and the demo stuff we already covered. But there's like a few things like I'll definitely mention in the future videos as well. After this, we'll be covering about images. So we haven't learned yet about Docker files. So for example, we haven't learned about how to create our own images. Kunal, Ubuntu and MySQL, MongoDB, whatever images you are downloading and everything, that's fine. They are already created on the cloud and we're just downloading those. What if I want to create my own image, my own container? Dockerfile, very simple stuff. So Dockerfile basically is like the recipe stuff that I talked about. Follow the recipe, you will create the dish. So here we mention what all things we need. From is the tag that we use. From basically means what is the base image. Let's just copy this. Okay, let me just copy this thing. So I'm going to say create Dockerfile. The name can be Dockerfile. This is convention. Capital D Dockerfile. I'm going to write it down from Ubuntu. This is like my maintainer. So I'm, let's say, Kunal. Just putting some random name over here just for documentation purpose. Run this command. Okay, while the container is being created, it will run this command. Since Ubuntu, there's a very popular command, apt-get update. It will run that. After that container is being created, run this command. 4 tags: from, maintainer, run, cmd. Exit out of it. Dockerfile is being created. Let's see how we can make an image out of it and what all these lines mean. Let's see that also. Okay, don't worry. Okay, so let's see what we have over here. Cat docker file. From Ubuntu, this line I can remove. Okay, no worries. I can remove that if you don't want, if you want to have like some basic stuff only. Okay, so I can remove this. Okay, I can remove this one also. Run apt-get. Okay, no problem. Let's say we have the basic Docker file. Okay, very basic Docker file. From Ubuntu, what does this mean? So this basically means that this is my base image, because every single image has some base image. Okay, if you're running this particular example, like my particular program is just saying hello world. That's it. Okay, so where is it saying hello world? Some base image is required. So that base image is basically Ubuntu. You can imagine this as like your operating system and stuff that you need. On top of that, you do your own work. CMD tag basically specifies what executables will run when the container has like started. So it's saying, okay, in the container, let's just run echo hello world. Just think of it as Linux. Everything is Linux. Okay, just think of it like that. It's very simple to understand then. Every image and everything you're running, whatever is doing, it's Linux. And Linux commands. That's it. Okay, you use the docker build command to build images. Okay, so you want to make an image out of it, you just say docker build command. You can give it your name. So for example, I can just modify a little bit. I can say something like, hello, my name is Kunal. Okay, that's it. The number of commands that I'm giving is in an array form. Okay, so that is what I want to mention also. So docker build, I can say my image, and I can give it a version 0. something like 1.001 or something. And then you have to specify the path to the Docker file. Where is the Docker file located? Current directory. Okay, if I just say Docker file, maybe I can add my own say run as well, probably, and apt-get update. That looks fine. Then I can run the docker build command. Now, before we create the images on our own, so using Dockerfile and stuff, we'll obviously be diving deep into Dockerfile, like containerizing big MERN stack applications, for example, even machine learning applications, and then just seeing some good practices as well. But for now, we have learned nothing. We have learned the from tag, which is the base image, a run tag, which is run this command when your container is being created, and CMD tag, which basically means what? Run this command when, like, it mentions some executables, so run this executable command when your container has started. Imagine everything is Linux. But the thing is that what if you have created your image, you want to share it with your friends and stuff? Where are all these images that we have worked on till now? Where are we getting that from? Docker Hub. I mentioned that already. Create your own account on Docker Hub so that you can upload your images also. Okay, sign into Docker Hub, and after that what you can do is sign into Docker Hub, and let me just sign in. Cool, so I have signed in. Kunal Kushwaha 99 is my username, for example. Then you just log in your Docker Hub account from the terminal. Okay, you say docker login, you say Kunal Kushwaha 99, password I'm giving it. Login successful. Now I can build my image. Okay, so now we have logged in and stuff. So what will happen is I say, now I have a Docker file. So I can say cat Docker file on my desktop saying from Ubuntu this version, this is my base image, run this command. Okay, that's it. That's my file. So I can run this command docker build. Where is the file? It's in my current directory. Okay, so docker CLI will talk to docker daemon and it will create my image for me. Okay, very simple. But the thing is that let me show you something. So if I just do that, or I can also do something like this. I can also add a tag and I can give my own image name, my image. So now the name will be of the image will be my image. You will see that it's saying sending build context to docker daemon. This will keep going on. It's very large. It's basically sending everything it is in my desktop to the daemon. Okay, for that you can use something like .docker ignore. Okay, you can create the git ignore file, like, so you can create .docker ignore file. Okay, I can say I can create a new file, project, move my Docker file in project to project, and I can say docker build this thing. Done. Are you able to understand why it was taking so long? Because my desktop has a lot of things. So it was sending all the data that was in my folder. Basically, whatever folder your Docker file in, when you build it, all the data in your folder will be sent to daemon, Docker daemon. I just created an empty folder and only had Docker file in it. Step 1, step 2. Step 1 is from Ubuntu this. Step 1 from Ubuntu this layer. Step 2 is CMD this thing, running this. That's it. Okay. Image is being created. My image. Docker run my image. That's weird. Echo not found. Does it not have echo in it? Let me just check once again, but you get the idea. It has echo in it. What's wrong? So let me exit out of the container. Dockerfile. Echo. Hello, my name is Kunal. Think it's because of some curly brace stuff. Let me just fix that. Yeah, I think it's because of the wrong braces. Okay, no problem. Docker images, remove this. Okay, and I can say Docker build my image, and I can say Docker images, my image. Very nice. So it was having basically, it was not having this one, it was having some curly double quotes. Okay, so the curly double quotes don't work, normal double quotes will work. That's it. So now you created your own image. How cool is that? Very nice, right? So that is basically about it. You can also go to the Docker desktop. You can see 3 images. So if you want to check out all the things that are, like if I say Docker images, 3 images are here, 3 images are here. You want to run it, you can do that, and it will create a container from it. You can delete it. So if you don't want to use the CLI, you can use the Docker desktop as well. Okay, so that is basically about it. Clean up, and you can do all sorts of things, check out volumes and containers and dev environments and everything. Okay, so that's basically about it. But that's not it. Like, we'll be doing more about Docker files is like we'll be doing heavily. So a few more things we need to look into, like in future videos, more about images, how to build images, how to share our own images to the cloud in Docker Hub, how to containerize applications using like Docker files and stuff, and Docker volumes you have to look into, image layers and stuff, networking, Docker Compose, Swarm, and Docker security, Dockerfile best practices, and all these other things. So I'll be making dedicated videos on this so that it's easier for you to understand. A few more things I want to cover. Let's move forward. Okay, let's move forward. Well, the last things I wanna cover in this video, and then the Docker part 1 will be over, and we'll upload more videos on part 2, part 3, part 4 of the things that I've just mentioned. So things we have been working with right now, like let's see how it works in action. So like the architecture of Docker and stuff. So the Docker engine that we are currently talking about, right? So we have a Docker client. Few things I want you to remember are these things. I already talked about the runtime, like runc and containerd. I talked about what containerd does, and it also manages runc. I talked about what runc does, and runc basically starts and stops containers for us. So these are just 2 runtimes. I also talked about Open Container Initiative, that there are many other runtimes. I also talked about the Open Container Initiative having 2 specifications, like image spec and container runtime spec, right? Things I talked about already. So it sort of defines like, okay, anyone can have their own runtime now, but they have to follow the rules that have been mentioned by Open Container Initiative about images and container runtime specs. Okay, so I gave you an example, a little bit of the Docker example, like why it does not really matter, because I just told it in this video only. Okay, make sure you check it out. Don't forget if it's a long video. Cool. So we talked about this thing, but let's see what the architecture look like. So we have the Docker client, and the Docker client communicates with the Docker daemon. Okay, the Docker daemon communicates with your containerd and stuff. Okay, containerd in itself then starts, it's a container runtime. So it's basically, it's a supervisor. So it supervises all the like things that are happening, like starting containers, stopping containers, or whatever. Okay, there's one more thing over here, like if we put out, so if we're making some containers, there's this thing known as shim, and we'll talk more about this later. Shim. Okay, then comes runc. Talked about runc already. Okay, starts and stops container, it's also a runtime. It's being managed by containerd, as we can see, and then our containers being created. My container is created. Let's see what all these things are about, and this is known as a Docker engine. This is my Docker engine. Okay, the thing we have been downloading and using is basically what it is. Let's move forward. So previously what happened was there was no there was only like Docker client and daemon and some Linux specific files. Okay, and that did not work out really well because like it was something known as LXC, and it was not like good for scaling. It was a monolithic architecture, and with the Open Container Initiative, it was like, hey, we need to do it a little bit better. Now we have the Open Container Initiative. They have stated some rules for us and we have to work with that. So then then came into picture, like they added like container D and run C and all these other things. So as you mentioned earlier, run C is basically a runtime, and it allows us to start and stop containers and something like that. Cool. So works on the lower level. On the higher level, we have container D that also manages the run C and everything, and it basically has it works with, let's say, the network. So remember the thing we talked about, like pushing and pulling images. Container D helps us in that. Container is a project by Linux, by this, it's the CNCF project, and one of the reasons for this, like first it was like for nitty-gritty stuff, but now it's like also being used in Kubernetes. Okay, so it itself as a special project is being used in Kubernetes also as a runtime. Okay, like I mentioned, I showed you the article, right? Deprecation of like Docker shim 1. Now they're using container D. So that's basically about it. Let's move forward and check out what these all things are. Okay, let me tell you an important point. What happens when we run the docker run command? Okay, so I'm saying docker run Ubuntu or whatever. So basically what is happening is that we given the Docker client, I say docker run, it talks to the Docker daemon, and the Docker daemon talks to container D. Okay, so it talks to container D using like CRUD operations and APIs and stuff over gRPC. gRPC. In Google it, it's very simple stuff. Okay, it's a protocol that is used by clients and servers to communicate basically. Okay, we've already talked about protocols in our networking video, so make sure you check it out. Okay, so container D is not the one who is creating containers. Okay, run C is doing that. Okay, so the Docker image that you provide, and it will tell container D will take that, it will tell run C like, hey, please create a container out of it. So run C will talk to your operating systems and like via kernels and everything, pull all the resources and create the container out of it. The good thing is that this container D, as you can see, it's separate from the daemon now. These are entities. So container D itself is a project. It was donated by, it was made by Docker and it was donated to, it was given to CNCF, and now it's a CNCF project. Okay, it's open source. You can check it out. I also have a hoodie of container D. I should be wearing that. Is this the one? No, it's Helm. Okay, it will make much more sense when we do Kubernetes. But anyway, so when we talk about this thing, let's see what the benefits are. So previously what used to happen, the daemon was the one that had all the like rules and logics and everything for containers. So once the daemon is stopped, the Docker daemon, if it's stopped, all the containers that are running, they will also be stopped. That is not cool. What if you want to update your daemon, want to maintain your daemon or something? Should it really impact the running containers? No, that's where comes into picture like container D and this shim thing. So basically what happens is, once the container is created, run C will be removed. Okay, run C's role is only starting container and stop just deleting starting container. So once the container is started, run C will not be there anymore. Okay, so need some sort of a way to sort of like manage these containers and talk to container D related to it. That's where shim comes in, this shim thing. Okay, so when run C goes out of scope, shim basically takes over. Okay, these are known as daemon-less containers, means when the daemon is down, containers will still be running. Okay, so that's basically about it. Cool. Okay, you might be wondering, Kunal, everything is done by container D and everything. Why have this additional layer over here, the daemon? Because it manages some images and networking part and all these other things as well. So the APIs, for example, with the Docker client has some functionalities, right? So we talked about it. So daemon is actually Docker D. It's in the Linux, Docker D, and you have container D, which is Docker container D. You have the shim, which is Docker container D shim, and you have run C, which is Docker run C in Linux. Okay. So these are just the names of the binaries. Okay, I'll just write the name of the binaries over here. Okay, so these are the binary files that are in the Linux system, if you want to check those out. Okay, don't ask me what are binary files. Okay, please check out the Linux videos that we did. Okay, you have to work a little bit hard and Google all these terms as well. It's important. And in DevOps, there's so many tools and stuff. Please make Googling your best friend. Okay, but I've already covered this. Nothing in this video I mentioned that I haven't already covered or promised to cover later on. Okay, So that was basically about like a little bit about the architecture and stuff. And yeah. Okay, and now when we're talking about like the Docker server and client, so when we talk about like, let's say, client and Docker like server, they're communicating with each other. Okay, so they're communicating via APIs and stuff. Okay, so if I talk about the on the HTTP endpoint, it's on port I believe 2375 or something. I think, yeah, that's it. I checked it. 2375. The thing is that over the network, when it's communicating over HTTP, HTTP is over the network and it's prone to, like, there's hackers and stuff. So it basically, for suitable connection, okay, Docker allows you to only accept the connections that are secured, for example, by TLS. What is transport layer security? Okay, transport layer security. You can learn more about TLS, but yeah, you can only allow that only the connections that are secured by TLS, and that way your connection between the Docker client and the server host will be safe. So this is actually a little bit advanced topic, and we'll cover such things later on. So I'll cover this in Docker security lecture, but this video was a great overview about how things work in general. So in the next videos, we'll learn more about images, learn more about some advanced Docker files, how to containerize your own applications. We'll learn about Kubernetes, we'll learn about Docker like networking, security, stuff like this, more Linux commands. We'll learn about Docker volumes, Docker compose, connecting various Docker containers together, Docker swarm as well, and yeah, a lot of things. So make sure you like, share, subscribe, and you can take a screenshot and stuff as well. Let me just add some nice little, yeah, this looks nice. Cool. So you can join the Learning in Public initiative, hashtag DevOps with Kunal, and check out the link in the description. Follow us on Twitter. Just show your support. Follow us everywhere. Share with your friends, and more videos will come very soon. Thanks a lot for watching. Make sure like, share, and subscribe, and do comment as well, because it helps in the reach of YouTube. Like, it grows the YouTube reach. And I'll see you in the next one. And please make sure you watch out for future Docker tutorials as well, and Kubernetes tutorials. I'll create separate playlist on Docker and Kubernetes on my channel. Go to the playlist section. We also have the complete like the data structure algorithm bootcamp that is also pretty amazing. So make sure you check it out for interview preparations. But yeah, that's pretty much about it. And we'll see you soon, and we'll cover some advanced practices as well. So yeah, thanks a lot for watching. Have a great day.